Hi, welcome back to the channel. Today we'll see integration by parts, also known as integration of products. We'll see three vivid examples. I'll solve the first two examples and I'll leave you with a third example. I'll place timestamps in this video to help you navigate through it. That said, let's get into class. Now, if you have a function like this, a first example, x squared ln x dx. This is known as integration by parts or integration of a product. We'll use our formula that says the integral of u dv is the same thing as vu minus the integral of v du. Now, the first thing we must do when we have this kind of issues is to identify which will be v and which will be u. Now, for convenience, let's try with. Now, if I am selecting my dv to be equals to ln x, that means I have to find the integral of v of dv to arrive at v. And this is not in my standard integral, so I know this is going to be a very challenging selection. Rather, I'll be selecting my u to be equals to ln x. If I say u is equals to ln x, obviously my dv will be the same thing as 1 over x. So I can now think of my dv to be the same thing as x squared. So if my dv is equals to x squared, then I can integrate both sides so that my v now will be the same thing as x raised to power 3 over 3. Remember, our formula says the integral of u dv will be the same thing as uv minus the integral of v du. That here we'll be substituting for u and for v. For u is ln x, and for v, that x raised to power 3 over 3 dot ln x minus the integral of v is x raised to power 3 over 3 du once more is dot 1 over x, so that I can plus c. Now I can rearrange this to become x raised to power 3 over 3 ln x minus, this is 1 over x here, then x here is 2. That's 1 all over 3 integral of x raised to power 2 plus c. So finally, that will be the same thing as x raised to power 3 over 3 ln x minus 1 over 3 dot x raised to power 3 over 3 plus c. Means if you look closely, I have x raised to power 3, I have x raised to power 3, and I have 1 over 3, 1 over 3. So I can factorize so that this becomes x raised to power 3 over 3 into ln x minus 1 over 3 plus c. Let's take a second example. For my second example, I want us to see the integral of x raised to power 2 e raised to power 3x dx. Now here, let's select our u and dv. Remember, the formula says that the integral of u dv will be the same thing as uv minus the integral of v du. Now here, I want to select my dv carefully. If I select my dv to be equals to x raised to power 2, on integrating, I'll be integrating v to be equals to x raised to power 3 over 3. Now it's getting more clumsy, so I will not go through this route. I'll rather say my u now is equals to x raised to power 2, so that my du will be the same thing as 2x. It's becoming simpler. And my dv is the same thing as e raised to power 3x, so that my v, if you integrate with function of a function, is the same thing as e raised to power 3x over 3. This is what we'll be working with, so that I can now repeat my formula and say that my integral of u dv is equals to uv minus the integral of v du. Now I can begin to substitute for u and for v, so that x squared e raised to power 3x with respect to the x will be the same thing as my u is x squared, my v is e raised to power 3x over 3 minus the integral of v e 3x raised to power 3x over 3 du is dot 2x. So that this is the same thing as 1, that's that's x squared, sorry, that's x squared e raised to power 3x over 3 minus 2 over 3, the integral of x e raised to power 3x with respect to the x again. Now we still have another integration by parts. And this time around, we'll also say that let my u this time around will be the same thing as x, my dv will be the same thing as e raised to power 3x, so that du will be the same thing as 1, and v will be the same thing as e raised to power 3x over 3. Then we can substitute just like we did in the first, just like we did initially. So that this will be the same thing as x squared e raised to power 3x over 3 minus 2 over 3 into, now for my u and v, I have x as my u, and v I have, this is x e raised to power 3x over 3 minus the integral of v is, the u is 1, and v, we left with v alone, that's e raised to power 3x over 3, bracket close, plus c. Let me create space, so that we can now expand this, my y, to be the same thing as, this is x squared e raised to power 3x over 3 minus 2 over 3 into x e raised to power 3x over 3 minus, I have the integral of e raised to power 3x over 3. That will simply become the integral of e raised to power 3x over 9 plus c. So that this is the same thing as x, this is the same thing as x squared. Now let's make it, now it looks a little bit clumsy, because I'll prefer we make it easier or simpler. We can see that there's a unique factor of 3 on the denominator and a unique factor of e raised to power 3x on the numerator. So I prefer to extract the factors of e raised to power 3x from the numerators and 3 from the denominator. That will be equals to e raised to power 3x over 3 into x squared minus 2 over 3x minus 2 over 9, bracket close, plus c, So here is our product. Now I will prefer you try your hands on e raised to power 3x sine x with respect to the x. I'll be glad you share your results with us through the comment section. That said, see you in our next class.